Good morning, everybody. Hope you're doing well. We're getting into our new unit on solving polynomials. So we're gonna start by going back over all of the factoring. So this is gonna be factoring polynomials. Gonna add in a couple new types, stuff you know. This is going to be a great reference sheet, so do not throw this away. Make sure you can do everything on here. And this will be a great reference sheet throughout the year going back and forth through factoring. So we got different methods of factoring. First, we got the GCF. Big thing with the GCF, we always start here. Always start with the GCF. If you can take out a GCF, then do it. The second one, the difference of squares, difference of cubes, and sum of cubes. I'm gonna cheat here. This always has, two terms. That's supposed to say terms. So those, I put that second for a reason because the difference of squares, difference of cubes, and sum of cubes always has two terms. If we're solving it, sum of squares does not work. So no sum of squares in solving because that's imaginary because that gave us the eyes in the back. If I have three terms, nice and simple, I put that with the third one for a reason. If you have three terms, we're going to take the GCF out first if possible. Then we're going to do the X factor or bottoms up. And then the new thing today we're going to talk about is the fourth one, it's grouping. So if you have four terms, we're going to group those. So that's kind of a run through. Depending on how many terms you have, depends on which method you might try. So what is factoring again? It's undistributing. D-I-S-T-R-I. Big word. So what we're doing is we're taking something out. We're not distributing it. So if we have something like 4x is my GCF, then say an x plus 3 and a 4x minus 7 or an x minus 2, it doesn't matter. This is what factoring is going to look like. If I distribute it out, I would get what I started with. So I'm going to walk through a bunch of different types. So this is a good thing to have. So you must know all of these. Thanks, Bill. So example one, we're always going to start with the GCF first. So I'm going to kind of zoom in on these so you can see. I'm still getting used to the camera. So what's in common in these? So 4x to the fourth plus 12x to the third. I can take out a 4 and I can also take out an x cubed. So what number goes into 4 and 12? The biggest number that goes into 4 and 12 is a 4. And then the biggest variable is x to the third. So I take that out. 4 divided by 4 is 1. I take 3 away from the 4x's, so I'm left with just an x. Now 12 divided by 4 is 3. And then my x's are all gone, so I'm good to go. So this, remember, is my GCF. The whole thing is factored form. So over here, b, 10y squared plus 4y minus 64. So I'm just looking at GCF, so everything I notice is even, so I know I can take out a 2. 4 is my smallest number, so I can't take out anything bigger than 4. 4 does not go into 10 evenly, so that's all I got. 64 does not have a y, so 2 is my GCF. If I divide everything by 2, I got a 5y squared plus 2y and a minus 32. And I get that factored. C, 8 and 16, I know they're both divisible by 8, so that's good. They both have at least one x. So that's going to give me 2x to the fourth minus 1. I know I'm going kind of quick, but you can always pause it and rewind it and go back and forth. So 8 and 16, the common number here is 8. And 8x just has one x. So that's why I can only take out one x. And then the last one, 36c to the ninth plus 12. They're both even. 36 is the multiple of 12, so I know I can take out a 12. 12 doesn't have a variable, so that's it. That's my only GCF. So I got a 3c to the ninth left over because I divide 36 and 12. 12 divided by 12 is 1. So that's a quick refresher on GCF. Now, difference of squares. Remember, if I have a squared minus b squared, I'm always going to get a plus b times a minus b. That is your formula for difference of squares. So pause it, write that down, make sure you have it. But that's what we're going to use. So here, 8x squared plus 50. Always, always, always look for a GCF. I know 8 and 50 are not perfect squares, but they're both even, so I can divide them both by 2. 50 is not divisible by 4, so I can't take out a 4. So I can just divide it by 2, so that gives me a 4x squared minus 25. And you see now 4 and 25 are perfect squares. So I got 2x squared here, 5 squared. So I can write them as perfect squares. So if you're comparing it to your formula, in a sense here, a would be 2x, b would be 5. So you would just plug those in. So I got a plus b times a minus b. So 2x plus 5, 2x minus 5. And then I had a GCF, so I need to bring my GCF down again. I cut off that parentheses, but it's okay. And I would get my factored term. All right, over here, x to the 4th minus 81. So x to the 4th, 4 is divisible by 2, so I can do that as x squared squared. And 81 is 9 squared, so that is nice and simple. So I would get a is kind of like x squared, b is kind of my 9, so x squared plus 9, and x squared minus 9. Now, looking at this is where we're going to kind of advance it. This right here is another difference of squares, because that is x squared, and 9 is 3 squared. So I can do that again here. So that would be x plus 3, x minus 3. That x squared minus 9 can factor down. Now the plus, that's my sum of squares. So now when we're breaking down further, that can't factor, so I'm just going to leave it. And this would be my factor completely. So if you're doing difference of squares, make sure you can't break it down further and further and further. All right, sum of cubes and difference of cubes. I'm gonna walk through both of those. If you look at the two new formulas, make sure you have those written down. You got them. You got the sum of squares above it, and then now we have sum of cubes and difference of cubes. Since it's a cube, signs don't really matter, so you can take the cube root of negative numbers. So we do have formulas for those. So look at the two formulas. You got a plus b times a squared minus ab plus b squared. And then for the difference, it's a minus b times a squared plus ab. So all you're doing is you're flipping those two signs. That's it. The rest of the formula is the exact same. So let's look at a couple of these. So here, excuse me, x cubed plus 8. So I know here the cube root of x cubed is just x. The cubed root of 8 is 2. So kind of go back over your cubes, your perfect cubes, 1, 8, 27, 64, 125. Those are your big key important ones that we're going to look at. So if I'm looking at my formula here, a is the same as x, b is going to be 2. So it's a sum. So if I write it down so you can see it, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So a is x, b is 2, so I got x plus 2. A squared, so x squared, minus going to multiply them together, so x times 2 is 2x. Excuse me. B squared, 2 is 4, and I'm good to go. So once you plug it into the formula, you are good to go. You don't have to factor any further. The formula factor it simply for you. All right, 81y to the 4th, 192y. So I got a sum. I'm looking here. Do I have a GCF first? Do I have a GCF first? So yeah, I can take out a 3. I can take out a y. So that's going to give me 27y to the 3rd plus 192 divided by 3 is 64. And I took out the y already, so I'm good to go. So this is, once again, my GCF. It's going to tag along. It's just going to stay outside. 27, the cube root of 27 is 3, y cubed, so I can rewrite that as 3y to the 3rd power. 64 is 4 to the 3rd power. So I have a sum of cubes. So I can write it down. So 3y plus 4. 3y times 3y is going to give me a 9y squared now. Plus, if I multiply them together, 3y times 4 is 12y. 4 squared, 4 times 4 is 16. So I have it factored. Oh, I got my signs. I screwed up my signs in the formula. This one should have been a minus sign. So we're good. Bring the GCF back down at the end, and you have your solution. Cool? So let's look at a difference, same concept. The only difference here now is I'm going to change the sign. So 8 is a perfect cube of 2, so I can rewrite that as 2x to the third power. 1 is nice and easy. So for my formula purpose, A is going to be 2x, B is 1. So I have 2x minus 1. 2x times 2x is 4x squared, plus now, multiply them together, you get 2x, plus always in the back, a 1, so you're good to go. If you want something that can help you out, to kind of help you remember this, and I'll do this next one, but for your sum and difference of cubes, you can do it for both of them, so let me put it in the middle. What you can remember is SOAP as an acronym, S-O-A-P. So same sign. For S-O is opposite sign. And then always positive. So if you SOAP it, same sign, always positive. So if you're looking on the left side, A plus, or the sum of two cubes, A cubed plus B cubed, you got the same sign, opposite sign, and then always positive. Same sign, opposite sign, always positive. That's a quick, easy way to remember things. All right, and then the last one on this page before I go to the other side. Z to the third power is always already done for you. 125 is 5 to the third. So same sign, so Z minus 5. Z squared, opposite sign. Multiply them together, so 5Z, and then always positive in the back. 5 squared is 25. And you got it. So same sign, opposite sign, and then always positive. SOAP it, and you are good to go. So that is our new thing. So GCF, difference of squares, sum of cubes, difference of cubes. Now, we got 3 more things to go. I know it's a long video, but you'll be all right. So X factor, we're gonna use 3 terms, and the leading coefficient is 1. So if the leading coefficient is 1, that's a 2, that's a 3. Last term is up top, middle term's on the bottom. So what factors of 2 add to give you 3? That's a 1 and a 2. So x plus 1, x plus 2. Kind of quick refresher. We've done this a lot, so I'm going to go kind of quick. So here, 6 in the back is positive, negative 5. What factors of 6 add to give you negative 5? So they both got to be the same sign, so negative 2 and negative 3. So x minus 2, x minus 3. Some quick hints. If your top number is positive, your signs both got to be the same. They both got to be positive or they both got to be negative. If your top number is a negative sign, one's positive, one's negative, so you're going to subtract. Or you're adding a negative, however you want to look at it. All right, when the leading coefficient is greater than 1, first, is there a GCF? Nope, 13 is odd and also prime. So here, remember, A times C. So 2 times 20 is 40. And 13. So what factors of 40 add to give you 13? That's an 8 and a 5. So x plus 8, x plus 5, and that's where we were. Now don't forget, you always got to divide it by the a term. So 8 divided by 2 is 4, so we're good there. 5 divided by 2 doesn't reduce, so I kick the 2 up. That's your bottoms up. I'm taking the bottom of this fraction, kicking it up. So that becomes a 2x. Sorry, I palm muted myself. I don't know what I missed. But it's okay. I'm not going to back up. So I kicked that 2x up. So x plus 4 and then 2x plus 5 are my factors. All right. 12x plus 14x minus 6. So I do see right here, I have a GCF of 2. So they're all even. So I got 6x squared plus 7x minus 3. So now that 2, that's my GCF. It's just going to hang out there. I'll come back to that at the end. So now let's look at my x factor with what I got. 6 times negative 3 is negative 18 to get 7. So now my top is a negative, so I'm going to subtract my numbers. So what numbers multiply to give you negative 18, add to give you 7? So that's a 9 and a negative 2. 9 minus 2 is 7. 7 is positive, so my bigger number is positive. So x plus 9, x minus 2. I got to divide them by 6. Now, always reduce your fractions. So 9 over 6 reduces to 3 halves. 2 over 6 reduces to negative 1/3. So I have this. I can keep that minus sign there. Get rid of that little one. Whoops, I did the wrong way. So minus 1/3. So reduce your fractions, and now we're gonna do our bottoms up. So the bottom of the fraction gets kicked in the front. So 2x plus 3, 3x minus 1, and then I had a GCF, so let's bring that back down here, and we're good to go. If you want to pause it and come back and check your answer for 3 or C or whatever this is, do it, try it on your own. If not, I'm just going to work through it. So 8 times negative 3, no GCF, so I got negative 24, that gives you 2. So what factors in negative 24 give you 2? A 6 and a negative 4. So x plus 6, x minus 4, divided by my a term, which is 8. So I can reduce fractions here. So they're both divisible by 2. So 3/4, 1/2, those are divisible by 4. So I kick it up. So 4x plus 3 and 2x minus 1, and I got it factored. Cool? All right, last one you need to know is if I have more terms. This is called grouping if you have 4 terms. This takes a little bit of practice, but you can be good. So what I'm going to do, make sure it's in order. It's in standard form. It's descending order. I'm going to group the first 2 together, and I'm going to group the second 2 together. I like to include the sign. That just helps me out. So I include the sign in the second one. To me, that just helps out a lot. So now I'm going to look at the first part. What's my GCF here? What's in common? I can take out an x squared. And if I do that, that leaves me with an x minus 2. Here, this sign I'm always going to take out. If this is a negative, I'm going to take it out too. So I'm going to take out a negative 9 here. That's going to leave me now with an x minus 2. Since that's a negative, I have to change this sign as well. So that's why I changed it to a negative 2, because if I FOIL it back out to get what I got, negative 9 times x is negative 9. Negative 9 times negative 2 gives me that positive 18. If you're doing grouping correctly, those 2 parentheses should be the exact same. So what I'm going to do is I'm going to take those out of the equation. So that's going to be my first set. So that goes here and here. And then what's left over? I got an x squared and I have a minus 9. That's going to be my second parentheses. X squared minus 9. And that is your grouping right here. One thing I do see here, looking at this, I put this here as a reason. This is your difference of squares. So remember, x is a perfect square, 9 is a perfect square, so that can break down into x plus 3, x minus 3, and then I just bring down my x minus 2. And that's where we got to get to. That is our factoring completely. It's factored down as far as it can go. All right, let's look at another grouping. 4 terms. This one's got a little bit more numbers on it, which is okay. So I'm going to group the first 2, group the second 2. These are all positive, so the signs are going to be easy. They're just going to remain positive. It's going to be a lot simpler for you. So my GCF here, I can take out a 3. I can take out an x squared also. If I do that, that leaves me with an x plus 6. Now the second side, I can take out a 7. Leaves me with an x plus 6. So I did it right because I know my parentheses are the same. So that's going to become my new first parentheses. So that's going to be here, here. If you want to cross it out to help visualize it, once you rewrite it, you're good to go. What's left over? A 3x squared and a positive 7. And that's going to be my second parentheses. And that is factoring by grouping. All right, one last one with a minus sign because those are a little bit more challenging. I also put a minus sign in the back on this one as well, just to see what happens. So my first set, I can take out an x squared. It leaves me with an x plus 2. We're good to go here. So since this is a minus, I can take out a minus 25. X, I got to change the sign. Or if you do negative 50 divided by negative 25, you get positive 2 as well. What I notice here, those are the same, so I did it right. So that becomes here. And then I'm left with x squared minus 25. So I got that. Am I done? Nope. That right here, once again, is your difference of squares. X and 5. So my final answer here is I'm going to bring down my x plus 2. And then my difference of squares with x plus 5 times x minus 5. And I got my answer. That is factored completely. So, best thing I can tell you to do is practice, practice, practice on factoring. You need to know how to do these very well. With what we added today, make sure you got your two new formulas, so sum of cubes and difference of cubes. You understand factoring as well by grouping. So you need to make sure you know all of these 4 methods up top. So once again, if you got questions, let me know. If I can help you with anything, please, please, please let me know. Other than that, hope you have a wonderful day. I know this is a long video, but please ask questions on your practice. Work through what you have, and we'll go from there. So thank you. Have a wonderful day, and I will talk to you later.